Welcome and good evening, everyone, one more time. Thank you for joining us today. It's a pleasure to have you all here. I'm particularly excited to introduce our um, guest speaker, Professor Jamie Ward. He is the professor of cognitive neuroscience at University of Sussex, United Kingdom, and he has published over 100 insightful scientific papers and books. And we have actually covered one of his very interesting books, The Student's Guide to Social Neuroscience. Thank you so much for accepting our invitation, Professor. How are you today?
I'm fine. Nice to meet you.
Nice to meet you too. I know you already know a bit about us. I'll just give you a brief recap of who we are, and then we will be all ears for your talk. I'm excited to introduce our group, the Iran Social Neurosciences School. We're a diverse group of students from very different backgrounds and universities and academic backgrounds, and we all share a common passion for social neuroscience. Over the past 11, 12 weeks, we have deepened our understanding of social neuroscience with covering your book. And now we're transitioning into our master classes. We have invited great researchers from around the world to hear their firsthand experience of what's going on in their labs and how they're doing the research. And in the end of the master classes, we will start our practical workshops, and we want to get some hands-on experience with the real methodologies that are used in social neuroscience. And today's schedule is we will start your talk for an hour, and then we will have a 30 minutes Q&A session. Yeah, so without further delay, you're all ears.
Okay, I assume you can see my slides, but let me know if there's a problem.
Yeah,
Um,
we can see your slides. Thank you.
okay. So today I'm going to give an overview of various topics in social neuroscience. Not all of them I've studied myself, but these are things that I teach and know about and that I've written about in my book. So it's kind of a broad overview and a little bit of a taster of the field, but also just kind of sharing what I regard as exciting um, aspects of social neuroscience. So today, these are some of the topics I'll talk about. So I'll talk about what we mean by the social brain and what is the evidence that actually the brain operates differently when it's processing social information as opposed to other kinds of information, and how that might be implemented, what's going on here and why. And then for the second part, I thought I would just pick a few topics that are of personal interest to me, that I think that there is a lot of work that's exciting and more to do for the future. And I thought it would be nice to talk about cross-cultural work with your group. So first of all, this is how I've kind of defined social neuroscience. So an attempt to understand and explain, using the methods and theories of neuroscience, how the thoughts, feelings, and behavior of individuals are influenced by the actual imagined or implied presence of others. This is actually a 1960s kind of definition of social psychology. And what I've done is that I've added a little bit underlined, which is giving it a more neuroscience feel. Actually, when we look at this definition, there's a lot of interest and complexity in here. So it's social, obviously, we understand as being other people. But actually, what this definition has is that it can be imagining other people, thinking about other people, and so on. And of course, this is important in our modern world. So now I'm having a social interaction with you, but we're doing it over the internet in a virtual surrounding. So I'm guessing that there are 90 humans there, but this is just an inference. I can't actually see you at the moment. So it feels like a social interaction, but actually, from my point of view, I'm just talking at a computer screen. And our brain can somehow, I suppose, engage in the simulation that I am. It's a simulated social experience rather than a real one, as I'm giving this talk. This is also a nice example that I use to kind of explain what I think is kind of really cool about social neuroscience. And essentially, what we're doing, what we're studying in social neuroscience, is how our brain is processing our thoughts about other people and how our own thoughts are influenced by others. And of course, when we're having a thought or when we're engaging in cognition, our brain is a big network of activity around the neurons, and one brain region will activate another brain region, and so on, because there are physical connections in the brain. But actually, when we're engaging in a social relationship, um, not only are different centers in our brain kind of talking to each other, in a kind of slightly bizarre sense, there's correlated activity between brains when people are having a social interaction. So this uses a method called hyperscanning, where you've got two people in two separate MRI scanners. You can do it with EEG and so on. Here, the people are playing a game. It's a trust game in which they are deciding how much money to give to the other player, and they're deciding how much to give back. The detail of the game isn't so important. But essentially, what you can do is that you can take activity in one person's brain, say an investor, and you can correlate it with activity in another person's brain and show that actually, when one person's making a decision to interact, the other person's brain is expecting the decision, and you have this close coupling of activity. Now, of course, this isn't to do with physical connections between the brains. All that's happening is that one person's brain is predicting how the other person's brain is responding because they know how other people behave. So you get correlated activity between the brains of different individuals simply by us being able to predict what other people are thinking. And it's a little bit like the correlated activity in our own brain, but obviously that is to do with shared physical connections rather than being able to predict at a distance. So I
I'm
started.
sorry, Professor. I'm sorry to interrupt. Your slides aren't moving for us. May I ask you to
Oh,
put the PowerPoint point on the slideshow? Now it moved. Yeah. Okay.
now it moves. Okay. Yes, I'm
Yeah.
sorry about this. So this is the example that I just gave, and you don't really need to see the graph. But what is interesting here is the idea that there is correlations between them. So as I click on, you can now. So now you see the next slide, right? Yeah.
Yeah. Yes. Thank you.
Okay. So as I said, what is it that makes something social? It can be an inference. Uh, And what is there are some clever studies in social neuroscience that effectively play on this. So you can have two scenarios that are physically identical, but in one scenario there is a social element and one there isn't. What do I mean by that? Uh, well, essentially, what you can do is that you can have a virtual interaction in which you are playing a game with somebody, but in one case, you're told that you're playing a game with a human. In another case, you're told that you're playing a game with a computer. So here you've got, and in both of these situations, you're actually playing against a computer, but in one case, you have a belief that there is another human there, a social thing. So these are very similar situations apart from the belief in one a scenario being social. So these are some games that they're called games. Belong to a class of things called behavioral economics or game theory, in which you're cooperating or competing with other players. So that's the social dimension. In the prisoner's dilemma, it used to be a dilemma that was set as to whether or not you and your partner go to prison, but actually the game that's played is a monetary version in which you are playing to earn money and another player is playing to do the same thing. And essentially, you've just got two things. One is that you can choose to cooperate with the other player, or you can choose to non-cooperate, and the other player does likewise with you. If you both choose to cooperate, then you both win $2. Okay. If you both choose not to cooperate, then you get a lower payoff. So this is a little bit like the game of life, in the sense of cooperating with each other is beneficial. You can do things together that you can't do separately. But what is interesting about this and what makes it a dilemma is that if you choose to cooperate and your partner doesn't choose to cooperate, they get a higher monetary payoff. They get $3 and you get 0. So the dilemma is that, to some extent, choosing not to cooperate can give you a bigger monetary payoff than choosing to cooperate, provided your opponent that doesn't play suit. So the dilemma is how you maximize your money being cooperative when there is the opportunity to not cooperate and kind of cheat on your opponent. What happens when you're playing this game is that you can experience emotion. So when you're both cooperating, you have a sense of trust and camaraderie. When you're cheating on each other, when you're both cheating, you end up hating the other player. This is what people report. And if one person cooperates and the other person doesn't cooperate, you can feel anger if you get cheated and guilt if you're the cheater. This is just what happens when you play the game over multiple rounds. So here, these are 20 rounds. And what you find is that people generally choose to cooperate. So mutual cooperation here, getting $2 each, is the kind of the norm. Whereas this scenario here is not so much the norm. On the last trial, obviously, you can see that the game's ending, so you choose to go for the big money, believing that your partner is going to retaliate. Here, what you find is that when you're playing against a computer, your behavior changes, that you cooperate a lot less. And this is, again, presumably because you're making the inference that the computer is not having these kind of emotions. The computer doesn't feel guilt or anger or hatred. So you can behave in a way that is maximizing your own individual gains here. But notice that in both of these scenarios, you are playing against a computer. In effect, this is a lie. You're not playing against a human. You just believe you're playing against a human. What happens in the brain when you're doing these kinds of decision making? So when you and your partner are engaged in mutual cooperation, then basically you activate parts of the brain that are involved in processing rewards. And these include things like the nucleus accumbens and the orbitofrontal cortex. So these respond to both social and non-social rewards. But what we find here is that they respond more when there is a social reward and in which you are cooperating with the others. And again, what's interesting about this is that the situation with the most money is the situation in which you are not being cooperative. So it's almost as if your brain uses its natural reward circuitry, which is used for both social and non-social rewards, and you almost like flip a switch when you are engaging with another human that encourages you to cooperate and sees cooperation as being a reward in and of itself. So when we cooperate with another human, it is rewarding, even if the amount of money you get is not the maximum reward that you can have. And this doesn't apply when you believe you're playing against a computer. So it seems as if you can kind of switch the circuitry of your brain to respond differently when you believe you're in a social situation. When you have unreciprocated cooperation, that's you cooperate, but your partner chooses not to, you don't activate the reward circuitry. You activate other parts of the emotional brain to do with perhaps to do with anger and disappointment. So these are your amygdala, your insula, and so on, which are perhaps to do with more negative emotions. And we can see this in another game. So this is the ultimatum game, where basically here you've got two players, and rather than playing lots of different rounds, you just have one decision to make. You're given some money, one person's given some money, and they decide how much money to share. Okay. So maybe this person decides to be kind, and they give half of their share to the others. The other player then has a decision to make whether or not they accept the offer, in which case both players get $10, or they reject it, in which case they get 0. So what is the correct way of kind of playing this game? Well, from an economic point of view, this person here should give as little as possible. So maybe they just give $1 or $2, and this person should accept whatever they're given. The reason they should accept whatever they're given is because something is better than nothing. Okay. What you tend to find is that this person rejects offers that they deem to be unfair. So it's almost as if they're trying to punish the other person. And they do this, whether or not they behave like this, again, depends on whether or not they think they're playing against a human or whether they think they're playing against a computer. So the optimal solution here is to give a low amount and accept anything you can got, but humans don't play like this. What they find is that that they will reject offers that are unfair. But again, they are more likely to accept an unfair offer if they believe they're playing against a computer, because you can't punish a computer, and you assume that the computer doesn't have any free choice in effect. What you also find is that when you reject an unfair offer, again, you're activating parts of the brain involved in emotion and creating kind of bodily signals of emotion, such as the insular and the anterior cingulate. But again, this neural circuitry depends on whether or not you believe you're playing against a human or playing against a computer. So for me, I find these really clever studies, because what you've got is situations in which you are cooperating or making social decisions, but actually you've got a very nice non-social condition that is matched, where you believe you're playing against a computer. So here, what's happening is that when you've got a social context, it's almost like having a switch in the brain, that you all of a sudden you use the brain in a different way when you believe you're interacting with somebody else. And the reason you do that is that you are assuming that the other person is having thoughts, that they're behaving in a way that's deliberate, and so on, that you treat them as being another agent capable of making decisions and capable of experiencing emotions. And we don't behave in this way when we're interacting with a computer. How does the brain kind of implement social functions? Well, one view is that basically there are specialized areas or circuits in the brain that are there for processing social information separately from non-social information. And this is often termed domain specificity, or we can just think of it as specialization. I won't go into detail with this, but again, some of the claims that have been made is that the kinds of social mechanisms that we have might be things like face perception or detecting biological motion. So humans move in certain ways that other stimuli don't. And that maybe we've got specialized circuits within our visual system for detecting humans perceptually. Another claim is that there might be specialized circuits that are involved in this thing called theory of mind. And all this is I suppose, again, the belief that other people have thoughts and feelings and so on, and our tendency to attribute thoughts and feelings and beliefs to other people. And this might be a separate mechanism within the brain. But again, these are controversial ideas. There are other kind of ideas that are pushed back at this as well. So some people argue that actually all humans have done is that they've just grown larger heads, and they've just grown more intelligence. And social intelligence is the same as non-social intelligence. So problem solving and so on with this. And it's just something that we can get through developing particular circuits. A related claim is what's often called the social brain idea, and that's that actually we've grown non-social intelligence by virtue of trying to be outwitting and competing and cooperating with others, that basically non-social intelligence has grown out of social intelligence. So this is an alternative viewpoint. Others have argued that there might be special kinds of neural mechanisms, so these might not be localized kind of in a modular kind of way. So there might be certain systems that are specialized for social information. And again, one of the claims made about this are what are called mirror systems. So I'll come back to this slide, but a mirror neuron is a neuron that when you record the number of action potentials, so this is what is shown in this graph here, that they respond both when you do something and when you see somebody else doing something. So it's like a bridge between you and other people. The original research was done in macaque monkeys to do with actions. So here the monkey is picking up a peanut and the mirror neuron fires. You've got this burst of activity in the neuron. Here the monkey is not picking up a peanut, it is watching a human pick up a peanut, and the mirror neuron also produces bursts of activity. One claim is that actually we don't just have it for observing actions like in the case of this, but we might have it for emotions such as pain, that when we experience pain and when we see somebody else in pain, that actually we've got a shared emotion, a shared system of pain that deals with our pain and for other people's pain and their emotions and their happiness. So we can literally feel the emotions of others around us by simulating it in our own brain. Now, whether or not these are, again, specifically social mechanisms, or whether we just learn them by paired associate learning in the same ways we might learn that in the summer the sun shines more than in the winter. Maybe that we just learn social information rather than have a dedicated mechanism that's innate or present from birth. So I won't give an answer to this, but essentially, what I would say is that clearly the brain behaves differently when it is engaging in social processing relative to non-social processing. How exactly it does that is a matter of debate, and perhaps we do have some modular-like mechanisms for dealing with certain things, perhaps like recognizing faces and bodies, and perhaps we have other things that are learnt on top of that. But this is one of the important challenges for the field: is what exactly is social versus non-social in the brain, and where does this come from? How does it develop, and so on. So this is my kind of take-home message from the first part of the talk, that being social is an act of inference. We assume that other people have feelings and that they feel pain in the same way as we do. But of course, we don't know that. Everything is this kind of inference. And when we make this inference, our brains operate in a different way. All of a sudden, when we believe we're cooperating with somebody else, we activate the reward system. And when we believe that we're interacting with, I don't know, a building or some other system that doesn't have feelings, we operate in a different way. This also enables us to progress in a technological way as well. So, for example, when I send a text message, all I'm doing is I'm just typing letters into a phone or a computer, but you're inferring that there is a social agent. When I type into Google, I'm doing exactly the same physical thing, but I don't assume that a human is reading it. I assume that a computer is processing these words. So again, sending a text versus typing into Google, it's the same physical action, but one is social and one is not social. And so we can engage in kind of these virtual interactions. Maybe we can engage in kind of humanoid robots. This is somebody called Sophia, who has a passport and so on. You can Google about Sophia or search on the internet. But again, to what extent are we willing to treat a robot as like a person if they start behaving like us? And science fiction obviously plays with this theme a lot. But again, humans have powerful imagination, and it creates these blurred boundaries as to where the social world ends and begins. In the second part of the talk, what I would like to do is tell you a little bit about some areas that I just think this is really cool, this is exciting. I would like to see a lot more research done in these areas. So again, they're slightly disconnected topics, but that was just a deliberate decision to kind of give you a little bit of a taste for different angles. So here, there's been an interest in how how social information is processed differently across cultures. A lot of this earlier research came about by studying participants in East Asia, so typically China, Japan, and Korea, versus the West, so Europe or America. So again, it's not taking into account the rest of the world, and that's one of the things that I think would be very interesting. Why people have focused on these is the idea that people have a different notion of the self. So the East Asian notion of the self is that the self is very much embedded within obligations to one's family, one's culture, and so on, and that you might, for example, follow in your father's footsteps, that you might carry on taking their jobs and their traditions and so on. Whereas a more Western or independent self attitude is, yes, you might still love your family, but ultimately you make your own way in life, you make your own decisions and so on. So it's a slightly different way of thinking about this. And again, these relate to the notions of collectivism versus individualism. What has been shown in a number of studies, and this is a review paper that was very nice, is that engaged in these particular cultural systems affects how the brain functions. What I think is also interesting, drawing back to the first part of my talk, is that it seems to affect how the brain functions also in non-social situations. So there have been a whole set of studies looking at how the brain responds and how your eyes move when you look at, for example, city scenes in which you've got objects and backgrounds, or scenes of countryside landscapes. What you find is that people from the West, so to speak, Europe and North America, tend to look a lot more at the objects, whereas people from East Asia look at the background and the interrelationship between the objects and the background. So you've got these processing styles, even when you look at non-social images, in terms of whether or not you're processing objects or the wider context. And you can see it in the brain, you can see it in eye movements. To some extent, even within a culture, you can shift your perspective to be either more individualistic or more collectivist. So these aren't things that obviously they are habits that people get into to think like this, but you can shift this with some flexibility. So this is a study that was done with Chinese participants. It doesn't have to be Chinese. You can do it in other cultures. What's interesting is that they read a set of text, and in one text, it's all about me. You've got the word I, my, and so on. So it's like an individualistic story that you're reading about one person. And another one, it's all about we. So it's about multiple people. So a kind of a group-based thing. What then happens is that you then, having read these stories, you then engage in a visual perception task. And here the visual perception task is to identify letters. So here there are two letters. There's a letter A, and there's a big letter, which is the letter H. Okay. What you find here is that when you've been focusing on the I story, so the individualistic or independent self, you're much faster at seeing the letter A, and you're slower at seeing the letter H. When you've been in reading the we story, so this kind of more social, multiple people kind of group thing, you're faster at seeing the H than in the I. So you've got this facilitation. So in effect, this is interesting because you've got this carryover from a kind of reading a social story here into a test of visual perception. And again, this happens very early on. So within 100 milliseconds of seeing this visual stimulus, you're processing it differently depending on whether or not you've thought of yourself as an individual, kind of a Western style mode, or you've thought more in terms of a we, this kind of more collectivist mode of thinking. And this can happen within individuals. Here, this is looking at activity in a part of the brain that again, tends to respond strongly to more social situations. So thinking about other people and thinking about yourself in relation to other people. So this part of the brain is called the medial prefrontal cortex. You can see it here. And people from all cultures activate this brain region when they're thinking about themselves, and to some extent when they're thinking about other people. What you also find is that this region tends to respond more strongly when you're thinking about yourself than when you're thinking about a stranger. So although it's a social part of the brain, it distinguishes between the self versus others more strongly. So in this particular task, what you're given is a set of personality adjectives. So whether you're brave, whether you're childish, or whatever, and you have to decide whether or not these adjectives apply to you, whether they apply to a politician, for example, who isn't somebody you know socially, versus your mother. What you find is that in the Chinese and the American participants, this part of the brain responds strongly when you process the self, and it responds less strongly when you process an other person, a politician or a stranger or something like this. But where the Chinese and the American participants differ is how they respond to thinking about their mother. So for the Chinese participants, when they think about their mother, it activates this part of the brain as if they're thinking about themselves. So it's almost as if their mother is part of their self-concept, this part of the brain is treating the mother like they treat themselves. In Americans, it's somewhere in between. So it's halfway between yourself and a stranger, which is how I kind of, but perhaps how I, think more about how I interact with my own mother is that somebody you care about and love, but it's perhaps less of a different kind of tie. What's interesting is that, like with the I and the we story, where you can flip between one thing and the other, if you're born in a bicultural thing, if you belong to two cultures, so these are Asian immigrants in the USA, that basically they can flip between a Chinese pattern of activity and an American pattern of activity just by context, depending on whether or not they think of themselves in terms of their whether they think of themselves in an individualistic way or collectivist way, a typical kind of American or a typical Chinese way. So again, it's as if the brain has these modes of thinking, but you can flip between one or the other, or you can train your brain to be more like a collectivist or an individualistic. So this is all well and good, except actually this literature is coming from some cultures more than others. We don't know very much about how social neuroscience operates, for example, in the Middle East, in Africa, in South America, other cultures that are a little bit different. Viv Vignoles is a social psychologist in my own institution at the University of Sussex, and he argues that actually this kind of notion of the West versus the Chinese kind of modes of thinking is too simplistic, and he argues that actually there are multiple ways in which culture can be fractionated according to being more independent versus interdependent, or more individualistic versus collectivist. So he argues that rather than it just being a simple kind of dichotomy, there are multiple dimensions in which you can be independent or interdependent. So again, he draws on some evidence from South America, also the Middle East. So he argues that the people in Egypt and Turkey and Middle Eastern countries, that in some respects they are more like Western modes of thinking, in that they can have strong self-reliance and the idea that you work for yourself and you make your own successes, and it's not up to the government to give you these successes. This is a kind of a Western way of thinking. But then they also have a more kind of Chinese or East Asian typical way of thinking, in that they like group harmony. They like the idea of respecting the group and respecting one's group values, which is a non-Western way of thinking. So in effect, some cultures can be independent in some ways and interdependent in other ways. And how this plays out in the brain, we don't yet know, but I would be very keen for people to think of culture in this more nuanced way than has been done in the past. So the last example of an area of research that I think is really exciting is around the relationship between the brain and the body. Now, of course, the brain is part of the body, but so what affects the body is going to affect the brain and so on. But what's very interesting is how that happens. What is the mechanism that does this? So there've been a whole set of studies looking at how social relationships can affect physical health. So social relationships would be the extent to which you have a close group of friends, the extent to which you feel connected. So it might be whether you're single or married, it might be things like this. But even if you're married, maybe your social relationship is not as good as it could be. Maybe you don't have a loving, caring a set of people who you can talk about your problems with. So it's not just about having social relationships, it's about the quality of those social relationships. It's about feeling loved, about feeling connected, about feeling you can share problems. So people who report being lonely or report having bad social support, this leads to problems in cardiovascular health, so your heart, your immune system, whole sets of other things. Being lonely is associated with a greater decline in the elderly. But this is kind of puzzling. So how does the brain affect, whether your heart is in good health? There are various mechanisms at play here, but again, one mechanism would be around that the brain triggers various hormone responses, and the brain responds to hormones as well as your body responding to hormones, and your brain can regulate certain hormones, such as a stress response or a kind of oxytocin, more loving kind of response. There are a set of studies where you simply look at an image of a loved one in a scanner. Samir Zeki, I think, he's of Iranian background. He's a researcher in London. But basically, he did a number of fMRI studies where you simply just look at an image of somebody you love. So it might be a family member, your mother, or it might be your wife or girlfriend, whatever, and compare that against a friend. And what you find is just looking at a loved one can activate these reward parts of the brain that I talked about before. When you're playing a cooperative game and winning money, just looking at somebody you love can activate your reward system of the brain. And it can also switch off parts of the brain. So parts of the brain involved in theory of mind might be processed somewhat different. So it suggests that you switch on the reward mechanism, but maybe if you have unconditional love, you don't try and guess somebody else's motives. You don't think about why they're behaving that way in a loved one. You accept them for what they are. That's one way of thinking about how this pattern brain activity works. So that's very interesting. Seeing a loved one can activate the reward parts of the brain, but actually it can affect things like stress and pain responses as well. So here, this is an experimental paradigm where you're looking at a loved one, but at the same time, you're getting a mild electric shock. So this is just people's subjective ratings here. So they get a little electrical shock, and in one condition, they are simply staring at a photograph of their partner, or they're staring at a photograph of a stranger, or they're staring at a photograph of an object. In this case, you're holding your partner's hand, or you're holding the hand of a stranger, or you're holding some kind of an object like a stress ball. What you find subjectively is that pain feels less painful when you're with somebody you love. Okay, this makes sense. People write novels about this. But what you find is that actually this analgesic effect is linked to the reward system of the brain. So feeling pain on your finger is less painful if you're with a loved one, and this is to do with the brain just changing the way it responds. In effect, you've got a kind of a love response along with a pain response. To some extent, it's a bit like a seesaw that they're balancing each other out and making stress and pain feel better than it really is. So here, these are just simple neural responses, again, just being in a social mindset, but a specific social mindset where you're with somebody you love. There are certain hormonal responses that are to do with falling in love and attachment in infants. So infants fall in love with their parents, and parents fall in love with their infants, and there are certain neural mechanisms that are responsible for that. One is these hormones called oxytocin and vasopressin, which have very similar chemical structures and are found in all mammals. Both men and women have oxytocin and vasopressin. There are some sex differences, so women are more sensitive to oxytocin, men are more sensitive to vasopressin, but actually both men and women have them. We know that this is involved in forming attachment behaviors or forming kind of loving relationships, because humans are not the only animals to fall in love. One other animal that falls in love are called prairie voles. They form a lifelong relationship with one another. They raise the children together. If one partner dies, they show a grieving response, and they don't necessarily go and find another mate. There is a very similar species called the prairie vole, who doesn't live in social family groupings. Obviously, they come together to mate, but that's it. They don't form loving relationships. So what is the difference between these two species? Well, both species have oxytocin and vasopressin, but this species, the social monogamous species, has lots of oxytocin and vasopressin receptors in the brain. So it's as if both animals have the hormones, but the brain is tuned to the hormones in the social loving species there. That they've got a lot of oxytocin and vasopressin receptors in regions like the amygdala, which suppresses the kind of fight and flight response. It's involved in certain fear-related behaviors, and it's also reward-related centers like the nucleus accumbens has oxytocin and vasopressin receptors. So again, there are these simple neurobiological mechanisms in hormones that are involved in forming and maintaining attachments. And we can study this experimentally. So in humans, you can administer oxytocin versus a placebo, You do this by sniffing it. Actually, when you take oxytocin relative to a placebo, and then you show fear stimuli, so these might be I don't know, somebody with a knife, or a snake, or about to attack, something like this, that you have a lower amygdala response. So again, it's like a buffering response in the same way as love can buffer against pain, it can buffer against fear. And oxytocin is one of the a hormonal response that does that. It can also increase trust on the trust game. So the trust game is one of the games that a little bit similar to the one I showed earlier, in which you're choosing to cooperate over multiple rounds with another person. But interestingly, oxytocin only increases trust on this game when you believe you're playing with a human. When you're playing with a computer, oxytocin doesn't have the same thing. So it has this social specificity here. And oxytocin and social support can work together. So here, this is a stress test called the Trier, the Trier stress test. And what you have to do here is that you have to give a speech. So, like I'm giving a speech to you guys, this would happen to an audience who would sit there and kind of give you kind of angry looks and so on. So this is giving a talk is a stressful thing. So it's a 2x2 design. In one case, you're given oxytocin, in another case, you're given a placebo. And in one case, whilst you're giving the talk, you've got your friend or your partner or somebody there, in the audience, giving you a bit of social support. What you find is that basically that when you have when you've got oxytocin, which are the here, and you've got your social support, this is the least stressful outcome. So here we've got a measure of stress on the y-axis, and this is a hormonal measure of stress. You're looking at cortisol. So cortisol is a stress response that you can detect in the blood or in your saliva in this case. So oxytocin with social support is the low stress option. Here, the high stress option is when you have no oxytocin, in orange, you've got a placebo, and you have no social support. You don't have your friend, you don't have your oxytocin, and your stress goes up to the maximum. And the other two are kind of intermediate. So again, oxytocin is important, but it also depends on the social context. Having your friend there can make things seem less stressful. But this actually plays out at the level of hormonal responses like cortisol. Cortisol also has effects on the heart, as does oxytocin. And again, this might be involved in some of the health-related issues as to why people who don't feel that they've got good social support, or who are lonely, that they are more susceptible to things like heart failure. The body and the brain interact in other ways. So here we've talked about the brain giving rise to hormonal responses that then affect the heart. So this would be oxytocin and stress-related hormones. But the brain is also interpreting the state of the body. So there are receptors that go from your heart and from your lungs that kind of detect whether or not somebody's panicking or whatever. And this can happen both consciously and unconsciously. So this is there are nerves from the periphery, from your guts and your heart that send signals to the brain. Your brain is interpreting what's going on. These signals in the body have long been linked to emotions. One earlier claim is that basically that all your emotions are just your brain's interpretation of what's going on in your body, your heart rate, your the sense of panic or joy or whatever it is. And again, as with this study with oxytocin, it seems to involve both social context as well as bodily physiology. So what Shakhtar and Singer did in their classic study is that they had something similar to the last design, where you kind of got a 2 by 2 design. So in one case, you've got a social context, that there's somebody who is making you happy or angry, uh, versus a non-social context. And the other case, you have you're given a hormone that increases your heart rate, adrenaline, makes your heart pump faster. If all an emotion is just sensing that your heart is feeling faster, then the social context wouldn't matter. What you find is that the social context is what triggers the emotion. But what happens is that if your heart is beating faster, you've got adrenaline, then the social context exaggerates it, makes happiness feel happier, and it makes anger more angry. In effect, it's like turning the dial up on an emotion if you have this strong bodily response. So again, we've got this top-down context of the social situation, plus we've got these other signals that come to bear. This is a study done by a colleague at Sussex that also looks at the heart and the processing of emotions. So your heart is a pump that is constantly beating, and it's got, in effect, a kind of a contraction phase, which is called systole, and a kind of a relaxing phase called diastole, where the blood comes in versus contracts. So you've got these two phases of the heart. What happens if you present a face really, really briefly is that sometimes you see the face and sometimes you don't. So here you can see on average that because the face is being presented briefly, it's being seen about half the time. What you find is that if you present a fearful face when your heart is pumping in systole, that you are more likely to detect it than when your heart is relaxing. And that's relatively specific to fear insofar as you don't find it for disgust or happiness, or here for neutral. Moreover, that when you see the fearful face, you are more likely to report it as more intense when you see fear on a heartbeat than not. So again, your brain is interpreting the body, and it is contributing to, in this case, a social perception of fear in somebody else. So this is where we're at in terms of presenting a summary. That basically behavior and its neural substrates are altered when a task is inferred as being social. So in various situations, as soon as you've got a social manipulation, it's like flipping a switch on the brain, is that all of a sudden you start to process things differently, maybe in terms of rewards, in terms of trying to understand what other people are thinking, that doesn't happen in non-social context. And I've given quite a few examples of this. How this specialization arises, whether this is really specific to this. So our reward system isn't just for social rewards, it's for non-social rewards. Have we learned to do this? When does it appear? And so on. The responsiveness of the social brain is tuned by cultural differences, but we know very little about this in most places of the world. It's come from typically East Asia and the West, and it would be very interesting to look at other places. And it's also dynamic. You can learn one pattern or another. The brain and the body are tightly coupled. This can be as a result of hormonal processes that obviously circulate throughout the whole body, that might be created in the brain but affect the heart and so on. But it might also be neural pathways, that there are neural signatures between the brain and the body in both directions that enables it to interpret certain things, and certain social information will activate the body and the brain in quite specific ways, as we saw in the case of oxytocin, the stress response, and the heartbeat. So I was absolutely thrilled to discover you were using my book. I hope you enjoy reading it. I'm very happy to receive feedback on it, and maybe one day I'll come and visit you in person in Iran. Thank you.
Thank you so much for your insightful lecture. We really enjoyed it. And thank you again for accepting our invitation. It was just so exciting for us having read your book for over 12 weeks and then having this opportunity to meet with you in person. It was really exciting and inspiring. Thank you so much, Professor.
You're
Now,
welcome.
we can just proceed to the Q&A. We can just filter some of the questions. Let me just start with a more general one. We want to know about your interest in social neuroscience. As we know, you have started your career as a cognitive neuroscientist, and we want to know what inspired this transition and why do you find social neuroscience interesting?
Yes, thank you. Yeah, my specific kind of interest in this came about through looking at um, I was very interested in the idea of mirror systems and the idea that we kind of create these simulations. So I'm particularly interested in things like pain and touch. And the idea that when you see somebody else in pain, that you might experience this yourself, or you might process this in terms of pain. So a lot of my research that is in the non-social realm is around how the senses interact with each other. So I was very interested in this idea that something like a private experience of pain can be kind of shared, and that we actually use some of our sensory machinery in order to process social information. And of course, that's kind of what mirror systems are: is that these are things that are looking at visual actions, but you process the visual action as a motor output or as a goal or an emotion, and so on. And that's one of the things that really kind of intrigued me, is that particular literature is what drew me in. And then obviously the more I read, the more I discovered actually that it is such a rich kind of field. I don't do research on hormones and things myself, but I think it's very cool.
Yeah, thank you. And the other questions with your role at Sussex overseeing a diverse range of projects, we want to know about the initiatives you're currently leading and what's going on in your lab and what's going on in yeah, Sussex generally in the realms of social
Sure.
neuroscience.
Yes, yeah. So we've got various researchers who I work with on this. So I've been looking at empathy and how this relates to particularly empathy for pain, and the context in which this matters, and also individual differences. So whether some people can be more empathic than others, and how that works, whether this is something that they can train themselves to do or not. So we have various studies that look at this, and looking at manipulating context. So if you think that somebody else is an unpleasant person, do you not experience their pain? Or does everybody always do that? Do you only experience the pain of people who you like? These are some of the research topics that we look at using fMRI and multivoxel pattern analysis, where you can look at individual voxels in fMRI to see what's going on. We have various studies that do more psychophysiological measures. So this is things like skin conductance and heart rate, and seeing how this relates to social context. So related to some of the similar the studies that I talked about with economic gains, about people deciding to give to charity. We can look at their skin conductance and show actually that sometimes their skin conductance um, shows a rather different pattern from their verbal reports. So often we have situations where do people want to give to a local charity, or do they want to give to a charity to help people in some faraway country? And what we find is that people often show a skin conductance response that says they want to give more locally, but actually and the skin conductance response is telling them to kind of give to the local charity, and their behavior is trying to pull away from that and kind of ignore their body's gut instinct. Uh, so we have colleagues who study interoception and heart rate and these psychophysiological responses. These are being done with myself and colleagues at Sussex.
That's so interesting and so nice. You're really interested in getting familiarized with the methodologies, the type of psychophysiological methodologies, and what you have explained. We have actually read some of your papers and tried to just read the methodology section. It was really interesting, specifically your research on synesthesia and how you approach such a very, I don't know, intricate, inaccessible thing, and how you actually study that. That was so interesting to
Yes,
us. And
yes, yeah, yeah. I didn't talk about statistics. It's less of the social one, but yes. So this is for those who don't know. It would be people who have colors when when they listen to music. They have visual images in their heads, and it doesn't seem to be problematic. You know, they're kind of a rather hidden subset within the population, but they do have differences in the way that their brains are wired. So I'm very interested in the notion of individual differences, and this is kind of there in my work in synesthesia. But this is also one of my interests in social neuroscience, is the idea that we can kind of experience the world differently from each other. To what extent is this a cultural thing that you kind of learn to uh, experience things in certain ways? To what extent is your brain wired differently that you can process pain differently when you see others and in pain, and these sorts of questions?
yeah, that's so interesting. And about synesthesia, what was really striking to us was um, some people can experience synesthesia when they're on drugs.
Yeah,
Are these different things? I mean, then you are inherently experiencing synesthesia, like for example in autism or other people. And if you experience that, particularly when you're on drugs, are they
yeah.
the same thing, or are they different?
Yeah, we don't know. I mean, you're right. You would imagine that there would be a connection. We, in terms of the kind of psychedelic drugs, they do work on known receptors. So it's actually one of the serotonin receptors. I think it's 5-HT2A. It's a particular receptor that these psychedelic drugs kind of act on. So it would be very interesting to know whether or not there are genetic polymorphisms in people who have naturally occurring synesthesia without being in drugs that would be in the same kind of neurotransmitter system or parts of it. That in effect that they have. This is what gives rise to these unusual experiences. Um, yeah, we don't know with regards to autism. So, synesthesia and autism go together. This is also one of my other kind of interests in social neurosciences. I suppose the social and the non-social symptoms of autism. So, autism is defined or has been defined more in terms of social communication problems, but actually, people with autism find sounds and lights to be very overwhelming and aversive. And the question is, why is that? Uh, One theory is that they have problems in predicting things in the world, and that would include in the social realm that they struggle to predict how other people are going to behave and think. And in the non social realm, it's that things feel overwhelming in the senses because they can't predict what they're going to feel like, or they can't suppress them based on their predictability. So lights and sounds feel overwhelming. But yeah, yeah,
I That was so nice. And may I just ask, why are you interested in synesthesia? It was the first time I was encountering this field of research, and I just really wanted to ask you in
yeah.
person what caused
That's
this
fine. Yeah,
interest.
yeah, it's a very good question. I mean, the obvious thing to say is that I don't have synesthesia myself, so I don't experience. these particular things. I think for me, the kinds of things that interested me as a student were yeah, I suppose neurological differences. Sometimes the ones that you see after stroke, that all of a sudden people lose the ability to recognize faces, or that they lose the ability to remember, certain things that happened yesterday, but they can remember things that happened 20 years ago. So I've always been interested in the idea of differences in the brain and how we can use that as a research tool, not just as a therapeutic or anything like this, but to actually understand what these differences mean, how the brain functions. So for me, I've kind of regarded synesthesia as being a model system for kind of understanding how the brain varies, how it can function differently, and so on, and sometimes in a way that is unhealthy, and sometimes in a way that is just different and it isn't necessarily a negative thing. Um, I also don't. People with synesthesia tend to think very strongly in visual images, whereas I'm at the opposite end of that spectrum. I don't have strong kind of visual imagery, and there is a name for that as well, aphantasia. So I think if I have anything, I have aphantasia, and I don't have synesthesia. But this is my own kind of personal interest. I've always been interested in, using kind of unusual or different kind of states of the brain, whether it's through brain damage, genetic differences, and so on. These kind of individual differences.
Yeah, I think it's really interesting to understand how great researchers have found their interest and how have found what they're going to dedicate their career in their life. This is why I asked, and thank you for your response. One of the questions our audience has asked is that if you want to draw a conceptual framework for the relationship between social cognition and executive functions, how should they describe their relationship? Which includes the other? Which one precedes the other?
So this is social neuroscience and executive functions. Is that correct?
Yeah.
Yes. Yeah. Yeah. That's very interesting. So the so executive functions are involved in kind of controlling all kinds of behavior, and this would apply to social as well as kind of non-social contexts. The way in which that they are often thought of playing a role is in things like emotion regulation. So again, people imagine that emotions are things that happen just in your subcortex, these very ancient kind of parts of the brain that you find in snakes and mice and so on. But actually, emotions are all around the brain. They're not just in one particular place. I mean, these regions like the amygdala are obviously important for emotions, but even your executive functions are kind of controlling and regulating those, or actively interpreting them. So I think for me, executive functions are around regulating um, the social context and the emotional context. I suppose to some extent it is what probably decides whether a situation is social or not. I don't think you're a robot, but I don't know for sure. But that's to some extent my executive functions on making that decision that this is social, so I'm going to process it via this mechanism, via that. So it can act as like a gatekeeper and a switch, and I suspect it is involved in those kinds of mechanisms in terms of controlling whether or not a situation is processed as in a social or non-social way, and if even when it is processed in a social way, they're regulating your emotional response, switching it on or off, or turning a negative into a positive, and these sorts of things.
Okay, thank you. Thank you for a great response. Now, I invite one of my friends, Mohammed, to ask the question himself. And I encourage everyone, you can ask your questions in the comment section. So I can ask your questions for you, or you can raise your hands and we can give you access to the microphone so you can interact with Professor yourself. Mohammed, go on.
Good evening, Professor. Can you hear me well?
Yeah.
Good. First, I want to convey my sincere gratitude for your amazing lecture. I think you don't have access to my webcam.
No, we cannot see you.
Uh, Wait seconds. I figure what it is. Okay. Now it, 1 second, sorry. I don't know why my webcam doesn't working well now. I express my question with voice. Sorry for this thing. Uh, After uh, hearing your amazing lecture, I have one question. It could be a bit far from the main topic of the lecture, but I would be grateful if you answer it. When we are talking about topics of social neuroscience and want to research in this field, some topics like social decision making, persuasion, or uh, uh, some kind of thing that kind of related to governments uh, unwantedly enter us in the world of political fronts and challenges. I don't know that I'm saying this correctly or not, but you can correct me if you want. Uh, in this term, we are facing with challenges in terms of legal institution in some country that have uh, some kind of restricted governmental institutions, and in more liberal countries, we have to deal with the funding problem. Some funding institutions just fund us if we think like the think that they want us to think. How you can see this thing? I think that could eventually lead us to some kind of biased result that we only publish and say things that uh, the government or the funding institution wants us to see and to tell and to publish. And if we don't talk about this thing or talk about this thing in lectures or some kind of media, we could be cancelled and uh, forced to leave the academia or something like that, or in closed governmental systems like some countries, uh, maybe we going to jail for that. How you think for this challenge in social neuroscience, how a social neuroscientist can deal with this, and is this a true argument that it could lead us to a kind of biased result or not? Thank you.
Hmm. Yeah, I mean, I don't know that a lot of the social decision making literature is looking at things like charity giving and so on. The extent to which it deals with political issues, I'm not so sure. There is a whole social neuroscience um, literature looking at yes, yeah. So, for example, in my book, there is a chapter kind of on morality, for example, which I guess would be a political issue in many places. To what extent people make moral judgments that are different from the norms of the society or the government, and so on. These are kind of interesting issues that I guess would be more problematic to look at. Um, yeah, but I don't think that I as a topic, I think that this is something that should be funded by governments, and I think it is easy to justify because I don't think that social neuroscience is trying to kind of speak against any kind of political system. It is about this is how people interact. I think what can be a problem is that people want to then say this is how people should interact, that they made that extra kind of inference that it's almost like a rule book. And that's not really what I'm trying to do. I'm saying, well, some people murder, but clearly that's not right. But the fact is it happens, and we can study this without, making a judgment value about this. I think it's interesting. There are studies, for example, that look a more kind of within a country like the USA, political conservative more versus more liberal approaches. And again, there are quite basic differences. That people who are more conservative in their approach have differences in like fear conditioning that are quite basic neurobiological mechanisms. And again, whether or not this means that some people are born to be more conservative, I don't know. Again, these are big questions that I guess would border on contentious, maybe.
Thank you for your response. Mohammed, if you want to
Thank you
ask
very
another
much.
question, it's okay, or I will just ask Puria to ask his
Uh,
question.
You can lead us to next question. Thank you.
Okay, thank
I try to
you.
answer.
Thank you.
Dear Puria, you have access to the voice and webcam. Are we ready for your question? We're not hearing you if you're talking. Let me give you access again. We still don't hear you, so let me just ask another question. You can just try to fix the problem with your voice and then ask your question. Um, One of the other questions is that about what is trending in the world of social neuroscience these days, and where do you think we will go in like 5 to 10 years in this field?
Yeah, no, it's a good question. It's hard to give one or two answers with this. I mean, I think the things that kind of interested me when I got in around mirror systems and so on are kind of controversial and perhaps, I wouldn't. There's been so much debate on this that I'm not entirely sure where this will go. I mean, they exist. What functions they actually have, we can debate. So I think that this area is a little bit more closed. I do think. The role of kind of hormones on behavior and how the brain regulates these, I think is interesting. In terms of how social support and loneliness affects physical health as well as mental health. I do find that an important area of research. Um, I think the literature on autism, this has kind of ballooned in recent decades, and I think again there is a strong societal kind of need to kind of understand and figure out what is autism, how do you um, deal with this as a difference, when is autism a problem and when is it not a problem. So these are interesting challenges. um, I think methodologically uh, that fMRI is still very important as a tool. I kind of do worry that because fMRI is kind of correlational, it's not you're not causally manipulating the brain that it's a bit over reliant on this, and I would like to see a kind of a greater diversity of methods used within the field. That's something that I would see as a new direction, or even within fMRI, just slightly more sophisticated tools that are kind of, I suppose, at the level of patterns of voxels rather than big blobs. So I think that we're still kind of labeling the brain as being, in terms of large blobs, rather than thinking about it in terms of information. But we don't really have the conceptual toolkit to do that. But for me, I think that there has to be some methodological advances either within fMRI or just tools other than fMRI. So again, the sorts of things we've talked about might be brain stimulation, it might be more other kinds of recording methods. It might be drug-based studies. I still think there's a role for this.
Oh, that's nice. Drug-based studies. What does that mean? What kind of drug-based studies?
Well, yes, exactly. Yeah, I don't. I mean, it could be administering drugs like oxytocin or whatever. Just to kind of look at how the particular circuits work, or there are ones that studies that look at the serotonin system, for example, and how this kind of shapes social behavior. So things like
Yeah, that's so
well, Prozac,
nice.
antidepressant drugs, they don't just affect depression; they have global effects on cognition and social behavior in ways we don't fully understand.
Yeah, and I just remembered that I've read a paper that was explaining the role of oxytocin in the ultimatum game you've just explained, and how it can just that changes the way people just behave. And also another interesting paper on Buddhists' difference in the ultimatum game, and how they actually, that fMRI studies show that they are activating different networks than other people when
Oh,
doing that ultimatum game, and they act kind of more rational, like accepting the lesser gains. That
yes.
was so beautiful. And thank you. And now I want to ask Purya to ask his question, if the problem is fixed. I think, Purya, we still can't hear. Oh, yeah, I will give you access again, and then we will proceed to Ali Reza. Purya, is it okay?
Okay, do you have my voice?
Yes.
All right. Hello, and thank you for the great lecture. And I would like to take the time to, in fact, send my gratitude to the School of Neuroscience for organizing such great events. All right, so Professor, my question is a bit interdisciplinary. I come from a literary background. I'm a student of English literature, and I've come across areas that, such as cognitive poetics, okay, that try to, in fact, bridge the gap between literary criticism and sort of neuroscientific literature. And my question in this regard is, you talked about studies that, in fact, investigate like Eastern culture, Western culture, and try to identify the differences between them, and probably in terms of neuroscience. My question is, if there are venues of research that can possibly offer novel insights in studying narratives, in studying literary works, in studying cultural canonical works, and sort of apply maybe neuroscientific methodologies through studying these sources. I'm not sure if I've made myself clear, but I tried to sketch it out the best way I can.
Yeah, I'm not sure. I mean, obviously, you can look at how the brain is responding when they're reading different kind of literary resources, and that there are things that essentially look at this. And if two people are listening to the same story or poem or whatever it is, you'll find that their brains are processing things in highly correlated ways. So again, that shared experience you're having in two brains, but you can then, I suppose, do this at a kind of a cross-cultural level, if that's your question, and seeing how whether my brain correlates with your brain, given we're from very different cultures, and what is it that's driving that. Um, and there is obviously a whole enterprise around neuroaesthetics, which is often kind of visual arts, but there's no reason why it couldn't be literary arts as well. But yeah, I'm not sure that answers your question.
Thank you so much. It does. Thank you.
Thank you for your question. And now we can continue with Fateme. I have given you access to the voice. Go on.
Thank you. I have access. My microphone has access. So my question is about the ultimatum game, the Prosper and Responder scheme. I just had this question whether there is, if what if we put this responder under some kind of pressure, under some kind of um, I don't know, some kind of a pressure, and see whether do they still reject these unfair offers, or do they accept it? I mean, has there been a study done on this ultimatum game, putting people under some kind of pressure and see how this changes?
Yeah, I don't have the kind of the details to hand, but somebody else kind of implied earlier, I think that the context will matter, and that people can,
Uh-huh.
change their strategy depending on um, either the rules of the game, who they think they're interacting with, and so on. And yes, so before it was around, Buddhists or people who are kind of monks or meditating might show a more kind of rational answer, for example. Um, yeah. So whether or not that would be the case if they hadn't trained themselves to be a monk, I don't know. But whether some people behave differently, uh, without that kind of experience. Um, yeah, but I would need to check. But I wouldn't doubt that this behaviour is quite flexible, because you can see it's flexible even in the situation of human versus computer. But then you can just vary who the human is and the context. So yeah.
Okay, and I have another question. I mean, this is more a general one. Will we have ethical challenges in future for this social neuroscience? And, for example, politicians may use it in their own favor, or I don't know, merchants and businessmen might use it for like marketing and these things, and use it in an unethical way. Will we have such challenges in future?
Potentially, I mean, yeah, um, it's hard to say how people can use it in an unethical way. I mean, the kinds of things I suppose I'm talking about is that if you treat people like objects, your brain can do bad things, and in a way you can,
Yes.
So if you imagine an organization as like an organization versus a group of people who comprise the organization, that these kinds of flips of the switch enable you to do things. But I mean, we already know this from human history anyway, that if you treat people as if they're not people, it gives you the license to do bad things. But in some extent, social neuroscience is kind of confirming that actually that you can dehumanize people, and then your brain doesn't treat them as social objects in the same way as with others. Um, but you can, of course, turn that to good uses as well. To make people more empathic or compassionate, or to treat organizations as a group of people rather than a kind of an entity, or you know a political thing. But yeah. Who knows? You can use it for good and bad as you can with anything. But I think we're just scientists, and we just try to understand how the brain works and make things better. And if other people don't make things better, that's on their conscience.
Yes. Thank you very much, and thanks for the nice lecture.
Thank you for your question. And now I want to ask Ali Raza to ask his question. I think you already have access to the microphone.
Thank you, Professor Ward, for your amazing lecture. And again, I have to say that it was a pleasure for us to have you here and learn from your experience. Actually, I have a question. Maybe it might be a little bit far from your lecture, but actually, it's a challenge. I think for it is for lots of students who are working on social neuroscience and learning from this field. As a matter of fact, we had a panel a couple of months ago on 12th Basic and Clinical Neuroscience Congress in Tehran. The topic was who is a social neuroscientist. We had a neurologist there, we had a psychologist, and we had a scientist, actually expert in the field of mathematics and physics. Actually, it was a great discussion, and it was, I guess, it was fruitful, but we couldn't come up with a conclusion. Actually, since lots of scientists are studying and working in this field, I mean, from psychology, from economy, from in the background of medicines, neurologists, psychiatrists. The thing is, who is a social neuroscientist? I mean, we can look at social neuroscience from different aspects, but how can we come up with a conclusion in this question? Thank you.
Mhm. Yeah. I think social neuroscience is still rather new to kind of have its own kind of rules or kind of governance, really. I mean, there are, it's, for whatever reason, most people who've come into social neuroscience have come in from a more kind of cognitive perspective. So people who are studying non-social things, and that's somebody like me who was, studying the senses and synesthesia and other things, and become interested. Um, it's a shame that social psychologists who have been studying social phenomenon, for a long time, they tend to be rather skeptical about neuroscience methods. Either they see it as reductionist or whatever, and I think that that's a little bit unfortunate that they uh, are less involved in social neuroscience than those with a more neuroscience background. I do think that medicine, certain branches of medicine, psychiatry, neurology, would be important to engage with. This, because again, they're seeing differences in the social brain, that are important to understand and clinically relevant. Um, most mental health problems have a social dimension to them, so uh, understanding this from the level of the brain, I think, is also um, important. Um, yeah, it should be an interdisciplinary field, really. But I think for whatever reason, it is coming from neuroscientists within kind of the psychology sort of background, at least in Europe.
Great, thank you for your answer. Thanks.
Thank you, Alireza. Dear professor, do you have time for like maybe 3 or 4 more questions?
Yes, it's absolutely fine. Yeah.
Okay, thank you. Ali, I will just give you access to the microphone and webcam. Let me know if there's a problem. We cannot hear you. We can see you, but we can.
Working, I think it's fine now. I had a question, Professor. You mentioned about the field of the empathy, and I don't know is it appropriate for asking this. There is a book about against the empathy, the rational compassion by Professor Paul Bloom. I just want to know your idea about some questions in that book in the politics, especially, and how that empathy can easily be manipulated. And because this is your field, it would be a great honor to give some point about that book and your idea about it.
Yeah, I really like this book, and I give it to my students to read. I don't necessarily agree with everything, but I can like things I don't agree with, and I like the fact that he's he's put together an argument that is kind of convincing. Of course, I'm not against empathy, and I don't think he is. He's simplified the field a little bit by um, talking about two kinds of empathy. One is affect sharing, which is what I was talking about earlier, where you see somebody in pain and you feel their pain. He is he's kind of that's the kind of empathy that he's against. What he argues, in effect, is that um, people tend to be empathic with um, their neighbors and their family and so on, and there are good reasons why. If you haven't got a sound family and neighbors, you're nothing. But we've grown up in a society where we only know our neighbors and our family. For all human history, we might know of people in China, but they're not. We don't see them. We don't know of them. So in a way, our brains are kind of tuned to this to people who are close to us. And in his book, he's effectively saying that's a problem because it means that we care about our best friend more than 10 other people. So if you would choose to save your best friend's life over 10 strangers' lives, and that's a problem. But for me, I don't think uh, if you want to kind of, I can see what the problem is. I suppose looking at it scientifically is that ultimately that is a mechanism that we have in our heads because supporting your friend makes a lot of sense because they're going to support you if you come up, if you're kind of, if somebody's trying to kill you, that's your friend's job. Uh, so we've kind of developed these local kind of mindsets that they just are what they are, and they've served their purpose in the past. And in the modern world, it is more problematic because you know we travel the world, we hear about events everywhere, we can influence events everywhere, and not everything is happening uh, immediately around us. So yeah, it does raise a lot of interesting questions. Yeah, I think his concepts of empathy are a little bit simplistic, but it was yeah, it's a good book.
And I had another question about the methodology. Most of the work it's done on the empathy and the neuroscience. With tools of the fMRI. You know, there are some countries like our country, Iran, the access to the fMRI is a little hard for all the students. In the terms of the methodology, how can we gain a good amount of the knowledge and good background in science with the EEG and ERP component? Uh,
Yeah, no, I think EEG is a perfectly good method for this as well. It's yeah, you can address similar questions, and it has some advantages. Um, yeah, I think EEG research is perfectly respectable in the field. Yeah, it's not problematic. It obviously does limit certain things that you could look at. But I'm a fan of psychophysiological measures, eye movement measures. There is lots of other things that can be done, and they're perfectly respectable.
yeah, thank you.
Thank you for your questions, Adi. And I think we can continue to with Shahrzad. Shahrzad, I'm just giving you access to webcam and microphone. I think we can hear you.
Can you hear me?
Yeah.
Okay. Hello, Professor. First of all, fantastic lecture. I really enjoyed that. And I love your books, Cognitive Neuroscience and Social Neuroscience. Actually, I've read some chapters of Cognitive Neuroscience, but I was planning to read Social Neuroscience. And my question is that what kind of suggestions can you give to young researchers in order to develop and actually have successful projects in this field and its journey? Because it's really wide, and although we have free materials like YouTube or these books. But I mean that how can actually young researchers can find their really true way in order to, and also um, I would actually say that that's in our university we are planning to read your books. I mean, cognitive neuroscience, actually regularly, every week or actually 2 weeks, and it's really interesting. And thank you.
Thank you. Yeah, I mean, I think my advice would just be, very curious. Be curious and open-minded. Don't believe everything you read. To try and discover things for yourself and make your own kind of judgments based on the evidence, um, would be a good kind of starting point. And I just think even if you choose something very narrow, that's absolutely fine, because it's about developing the skills as a researcher. And once you've done that, you can apply it to any um, question you want. So don't be scared about being narrow. Just be very thorough in what it is you do, and check everything, check things replicate. Be very conscientious and open-minded about things, because we're discovering things all the time that are new, and some things that we thought are true maybe aren't so true. I don't know, but that would be my advice for a starting researcher.
Thank you for your response. And I will just ask one question from the comments, and then we can continue with Kian. The question was, can we really generalize the results of the experiments that are done in labs to the real life context? And how can we approach this problem?
Yeah, that's a very good question. Yeah, I think I think in a lot of cases, you can see kind of analogs of or similar things to things like the ultimatum game, in real life, that people seem to behave in a way that's irrational, and it's actually not irrational. It's just that they are being influenced by the social context rather than the actual kind of the raw decision. There are plenty of anecdotes that would do that, but yes, I think the kind of methods we use, whether it's EEG or fMRI, they are problematic methods, because you can't do them in the real world. You have to have these fairly contrived scenarios. I think what I take hold of is that basically um, that our brains are just very good at kind of imagining and simulating real life. It's just what we do the whole time. When we watch movies, when we read books, these are all imaginations and simulations and thoughts and so on. So actually, I think a lot of the data we are collecting in the lab is kind of authentic, because we can create such kind of good simulations. We can imagine the social world. Most of our social interactions are through screens and text, and so on, and we don't find that problematic. It's natural. But yeah, it does worry you that it could be a cause of concern that you're creating an unnatural social context by putting somebody in a lab with an experimenter and some equipment and these sorts of things, and whether or not the participant can really ignore that in order to do what you want them to do. Who knows? Yeah.
Thank you for your response. Now, I think we can go to Kian. Kian, do you still want to ask your question? I can give you, if you raise your hand, I will give you access to the microphone. And maybe I can just ask one of the other questions. Actually, I myself, I'm so interested to understand where you yourself are gonna go. Are you going to continue with synesthesia and what you're currently doing and the papers we've seen, or are you going to have a transition? But I think before that, I need to access to Kian. He has been waiting for so long. Sorry, Kian, go on.
Okay, is my voice clear now?
Yes.
Okay, great. I'm going to repeat my, let me turn up the camera. Okay. I'm going to repeat my question that I've already written. Professor, how do you foresee the prospects of this field of study in Iran specifically?
Yeah, well, I'm very impressed that you are, aware of this field, and I think that you do great research. Your country does, as far as I know, supports research and university education. Um, I think I don't know whether undergraduates are taught in this field, but I think that this would also be important rather than self-discovery. And obviously, you're thinking of ways of spreading the word. So I think getting more people interested and involved is great. Um, we can think of developing other sorts of links. It's nice that you're inviting people to speak. It's important that we get to hear from you as you do your research. It shouldn't just be Western experts coming and telling you, ideas. We want your ideas coming to us as well. And I think we need to think about how we can create those channels of communication.
Great, and let me brief you beforehand on a few points. I'm going to pose a question. I'm an English literature student right now, and I am looking for doing my education on psychology, maybe even as far as stepping into the neuroscience field. How do you think psychology and neuroscience will overlap during time? Are they going to match at any point without having the possibility of being separated whatsoever?
Yes, yeah. I mean, it's a lot of people when they go into psychology, are obviously interested in therapy and counseling, um, whereas academic psychology as a discipline is different. Um, so, I mean, relating to one of the other questions, obviously things like medicine and so on do feed into social neuroscience, neurology and psychiatry, and so on. Um, yeah, I'm not sure. Uh, yeah, I think I think psychology and neuroscience are a good match because ultimately neuroscience is just a method and psychology is the thing that's asking the questions. That's how I kind of think of it.
Great, thank you. I think I got my answer. I'm going to let others speak.
Thank you, dear Kian. Professor, if we end the session in like 10 minutes, would it be okay for you, or we need to just
I think 10 minutes is good. Yes, yeah.
close it sooner? 10, 10
10
minutes
minutes is
is good.
fine.
Okay, thank you. So, another question which was really interesting is that in your book, in the Student's Guide to Social Neuroscience, you have included a 2013 article which was giving an overview of the field as it was in 2013. It was explaining that the current research interest of most of the people active in the field of social neuroscience was, for example, clinical disorders, self-regulation, and it mentioned that the social neuroscience is currently lacking methodological rigor and ecological validity, specifically about the things that social neuroscience was lacking in 2013. We're interested to know how has this changed over this 10 years, and how the portrait of social neuroscience has changed from that time on.
Yeah, I'm not sure I have a definite answer. I think one of the things that is happening is larger samples. So that has been driven by journal requirements and so on. So there's a worry that um, some results with smaller samples don't always replicate, or you miss out on small effects, and you only ever see very large effects, and small effects can be interesting. Um, so I do think that the field has started to address that because it's a general concern in psychology and neuroscience. Um, whether it lacks conceptual rigor, I mean, I think. Yeah, I think that we still kind of struggle with certain things like what are emotions, and there isn't a single agreed theory on this, and some people argue that emotions are just learnt from experience, and that this is Lisa Feldman Barrett's view. Animals don't have emotions. This is, she comes out with this claim. I'm not sure I believe that, but there are still these kind of controversial ideas that I don't think are fully resolved. So, and if we can't kind of understand, core constructs like what is an emotion, the field itself is going to struggle to move on. But these ideas still remain somewhat contested.
Thank you. And one of our audience has asked that what are your thoughts on interdisciplinary field of social neuroscience, architecture, and urban planning? And can you suggest potential research topics in the area? It's nice how everything is just having, I don't know, getting attached to neuroscience and social neuroscience, even architecture, art, music. I think it's an interesting question.
Mhm. Yeah, again, with regards to the person asking about literature and poetry, I guess it would be, understanding how the brain processes the built environment and interprets them. You could you look at it this way, um, but yeah, in terms of the creative process, I suppose to what extent. This involves an aspect of social decision making in that one person doesn't design or make a building. It requires cooperation and collaboration. Um, how do you make a collective decision amongst a group of people? I suppose social neuroscience can speak to that when you're uh, doing kind of complex activities such as this.
Thank you. And just this is two last questions. Where are you going to go? Are you going to continue with synesthesia, or what are your
Oh
interests?
yeah, no. So at the moment, research on synesthesia and autism are the things that are kind of interesting me the most. I would imagine, and they're slightly overlapping, slightly different sets of research. I enjoy collaborating with others. So, like I say, I've got colleagues who are doing um, altruism. So this is kind of donating to charities and things like this from a social neuroscience perspective, and I enjoy working with them. But I wouldn't imagine um, changing too much at this point. I'm kind of quite happy with where I am. It's like if I started again, where would I go? I don't know, but I really enjoyed studying what I've studied and learning about a very broad range of things.
Thank you. And for the last question, can you give us a take-home message? And it was really exciting to meet with you. We are all in the beginning of our pathways as researchers or people who are interested in social neuroscience and neuroscience in broader terms. What are the things that you think we can learn, or how can we just find our interest? How can we find out good positions in the realms of the research, specifically in our country? It's really difficult to find positions, fundings, and a lot of us are just going to immigrate, and we want a take-home message.
Yeah, I mean, stay curious, stay positive. I mean, try to kind of fulfill your dreams around this. Even if you did have to study in another country, your skills will be important for your country. It's I think it's great that you are being collective about what you're doing. The fact that you've set up your Iran Social Neuroscience School, that you are doing everything right by trying to make a joined up effort. Um, and it's good that you're reaching out to researchers elsewhere in the world. I think that these are important moves. There is one online conference called the Society for Social Neuroscience. I don't know how easy it would be for people in Iran to register, but coronavirus has done some good in the world and as well as bad in the world. And one of the things is having more virtual meetings and good platforms for this. And there are more virtual meetings happening in social neuroscience that people in Iran, I'm sure, can participate in.
Thank you so much. And now I just invite everyone who might like to turn on their webcams, and so we will just take a photo, and then we can end our session. I can give you, just raise your hands. I will give you access to webcams if you like. Mohammed and Ali Reza, if you can, I would like to turn on your webcams. Okay. Ali Reza, is there... Professor, your webcam is turned off.
No, I think you've turned it off.
I did that. I'm sorry.
Oh, no,
Maybe
no,
I
no,
think.
I've got it now. Okay, turn on webcam. Yeah, I don't know why I did this.
Okay.
Oh, no, it's got a limit of 4 videos at the same time. It says on
But we're
there.
3. Maybe. Can you please? I think we're
I think it's a
3.
limit for webcam video.
It's.
It's
I
limited
think the
to
limit
5 video, I think.
is
I'm
4.
back.
Isn't it 4? Okay, okay. Thank you so much. So, on behalf of Iran Social Neuroscience, I thank you. It was really great to see you. I'm really excited, and it was a great opportunity. I do not have enough words to thank you. Thank you, and we hope to see you again in our future events. Have a wonderful, I don't know, is it night or day?
Yeah, evening. Yeah.
Have a wonderful evening.
Okay, nice to meet you all. Thank you so
Thank
much for
you.
your questions.
Thank you so much, Professor.
Bye-bye.
Bye bye. Thank you. Good evening.